All right, Kevin, all you.
Alrighty, go ahead and share my screen. Let's do entire screen. Alright, it's coming through. What are you guys looking at right now?
Terraform by Kevin Harrow.
Sweet.
Slick presentation.
Super
Oh,
excited
yeah.
because Terraform has been blowing up at my work, so I'm interested to hear anything you have to share with it. So go for it, man.
Okay, cool. Yeah. So has anybody worked with it or heard of it? Just kind of open discussion to start it out. What's people's thoughts on Terraform?
We use Terraform.
I only know what it does.
I'm completely new.
Me too.
So
Heard about it a lot, but haven't used it.
at VMware being an infrastructure company, they essentially tried to ignore it for a long time, but it's really become an industry standard. And like at a high level, it allows you to write code that can be stored in a source code repository to describe your application in a modular way. So you can say, we need 5 servers, 3 of them are behind a load balancer, and then there's firewall rules, and these ports need to be open, and that code could be interpreted by, in my understanding, a number of different platforms. So you could have you could have something that takes that and deploys the application into Amazon AWS, Google Cloud Compute, on-premises vSphere, OpenStack, any number of things. But it's essentially like a hardware-agnostic way to describe the infrastructure that hosts an application, is my high-level understanding. And I'll let Kevin give more on that if he needs it.
Yeah, that's pretty much the gist. We'll go through it a little bit, kind of in depth, but that's a really good explanation. So today we're going to be really looking at kind of the basics of Terraform, how you do like a general workflow, and we're going to be using kind of setting up a Lambda for that kind of explanation, that demo. But you can swap that out for any other compute instance that you want. But yeah, we'll get more to that a little bit later. So, right, what is Terraform? So Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. So this is from their website. Terraform can manage existing and popular service providers as well as custom in-house solutions. So the key being, building, changing, and versioning infrastructure. So infrastructure, in this case, full stack meetup is anything that you need to get a service working, your app, compute instances, storage, networking, DNS entries, software as a service features, and there's all the cloud providers have their share of modules that we'll get into later. So you can pretty much host anything. So that's kind of the building and changing aspect of it, and Justin touched on this idea of versioning that infrastructure. So how do you version a server, or how do you version a set of Lambdas? Terraform uses this concept of infrastructure as code. So it uses kind of this configuration syntax, high-level configuration syntax, to kind of script out all of the resources that you need. So this allows a blueprint of your data center, basically, and you can version that and treat that as you would any other code. So it goes right in the source control. Additionally, infrastructure can be shared and reused, which is one of the really good selling points, that you don't have to just spend your time kind of making the script that sets up your infrastructures. You can then reuse it between different environments. If you had to set up a dev environment, QA, a pre-production, production, or even like at the branch level for your workflow, all that infrastructure is basically there, and you just have to put in like a workspace variable or something, or an environment type variable to duplicate all that infrastructure. So at a very high level, this is basically what this configuration syntax, this high level configuration syntax looks like. This is just your infrastructure.tf file. You can name it like main.tf. And this houses basically everything you need to set up a simple Lambda. So this is already assumes that your Lambda's good to go. It's been packaged in your zip and you're ready to deploy it. And we'll get more into this later, so no need to make your eyes bleed. Just really quick touching on key features of Terraform. So we talked about infrastructure as code. You can take something that looks like this, version control it, and then as you make changes, you can go back, all that good stuff. Execution plans are something kind of unique that I've found that Terraform provides, which is the idea that when you do a deploy potentially of infrastructure and something isn't quite configured correctly and there ends up being an error, your infrastructure hopefully can roll back and then there's no harm done. It could just break and then you have to fix it and then you're not up and running until that deploy is actually good to go. The concept of execution plans in Terraform are kind of like dipping your toe in the water. It's like a pre-plan step, or like a pre-deploy step. So you can kind of see if anything's going to error or basically if anything's going to error, and then you can fix those. It also allows you to kind of see exactly what's going to be changing and if that's to your expectation. A little bit lighter key features, but resource graphs is an interesting piece. You can, with the CLI, you can run Terraform graph and it spits out this kind of thing, which isn't super pretty right now, but you can pipe it to this tool that they recommend, and then it actually creates somewhat useful representation of your infrastructure. So after everything's said and done, this is basically the infrastructure that we're going to be setting up today. Well, I won't go super deep into this, but it's kind of a neat thing that Terraform provides is resource graphs. I assume it's more useful than just that, but that's kind of, I just glossed over it. So change automation is really just, this is kind of like a script, right? It's kind of, you're putting all of this into, you're automating it. So whenever you automate, right, you get the benefits of that, reducing manual steps, and that's its own benefit. So kind of just going quickly through use cases, right? If you've deployed any of these kind of infrastructures, you probably have an idea right now of how you can use this for something that you might be developing. So, just going from the top down, Heroku app setup, you can set that up pretty easily in that script, like on that server, but then CNAME and CDN kind of come after or like another step in that process of deploying. So you can actually bundle that all with Terraform. Multi-tiered applications, self-service clusters, if you have a large organization and segments of that organization have their own clusters, then it's a little bit advantageous for that. Software demos, disposable environments, if you wanted to create multiple redundant environments, like I was kind of mentioning earlier, if you wanted to create them per branch to deploy things on a per branch level while you're doing development. Software-defined networking, resource schedulers, making sure everything runs when you want it to. And then multi-cloud deployment, which is also something that Justin mentioned, which is the concept that you can deploy these infrastructures across multiple clouds. It's kind of agnostic in that sense. You do have to, unless there's like a more general way to pump all of your infrastructure through. So, for example, you wanted one set of instructions to deploy to 3 cloud services. That might be a little special, but right now I would probably just set that up redundantly so that you would have one for Google Cloud, one for AWS, one for VM or whatever. But yeah, just some things you can do with it to be aware of. So yeah.
I was going to insert something just as a side comment here. A lot of people, you hear this term DevOps being thrown around a lot, and this is the sort of technology that makes that sort of thing happen. So you hear a lot of people that the dream is, I write some Python, I write some code, I check it into GitHub, and that's all I have to do. It gets deployed to like basically a live test environment. The stuff that sits in between your Python code getting published and put up on a server that's deployed and running is something like Terraform. And you can use, there's a variety of software out there, but a lot of them use basically something like Terraform to describe the infrastructure in a programmatic way that allows you to achieve that, so that you can check your code into source control, and something like TeamCity or something like some sort of CI/CD pipeline essentially invokes a deployment that uses Terraform as a description to basically deploy some servers to a hypervisor, to a public cloud, to a private cloud, that's either running VMware or running OpenStack open source, or running whatever, and get all the software installed and configured. So being able to have something that describes how that infrastructure could be or should be configured as code is an important piece of that dream scenario for developers, which is I write code, I check it into a source code repository, and something else picks up that code, deploys it to a test environment on a server, runs tests. If the tests pass, somebody else clicks a button and then it gets deployed to prod or something along those lines. So this is a piece of that grand puzzle that people call basically DevOps, or infrastructure as code, and all those pieces.
Yeah, definitely. Yeah, anybody else?
Yeah, can I add? I mean, there's multiple ways to do that, CI/CD, but the real reason we adopted it was because of the modularity and the extensive coverage in the deployment targets. So the time it takes to deploy or to build the templates and maintain the templates for AWS versus CloudForms is minuscule. So similarly, it's got complete coverage for Azure. So if we want to deploy into Azure, we can pull the modules, build our custom modules, and the amount of code that we've written and maintained is very small. So we can depend on them to be up to date and to have that coverage. And the same with deploying into VMware. We deploy into GCP, VMware, AWS, and Azure on a regular basis. But it's really been, if we had been trying to do this, say, with ARM in Azure, it's not even a contest. Our ARM is ugly and nasty. So being able to get Terraform to just build our Kubernetes cluster with all the right telemetry and networking and the enterprise standards and a handful of modules, it's really been nice.
So that's interesting. You're not only using containerization, but you're actually using Terraform to deploy your container hosts.
Yeah, so
cool.
to an unlikely series of circumstances, I became a principal architect for a major organization, and I'm afraid we have the need to stamp out Kubernetes clusters on a regular basis.
They should be, in my opinion. When you move to containerization or virtualization, your infrastructure should be mutable. That is, it should be non-persistent, where if you need to redeploy it or you should be able at any point to delete it and recreate it based off source code that describes the infrastructure in some sort of way. So that makes total sense to me.
But we want to like when we upgrade our Kubernetes version, we just slap down the new one.
You blow it away and deploy a new one, and then roll out your containers in the new. Yeah, makes total sense.
And likewise, all our core build is in Terraform. So, I've got a massive, build. I think I don't know. It's $100 million footprint in each cloud, and we can slap the whole thing down with a Kubernetes build. Completely new in the new region or whatever at the drop of a hat. So that's our full redundancy backup, right?
Yeah. What organization do you work for again? I don't recall if you mentioned that again.
I work for Providence.
Oh, Providence. That's right. We talked about this. I was going to say $100 million worth of infrastructure is not small potatoes. So wow.
It's not large. Where we're going is much bigger. So
yeah. Well, Providence has been growing via acquisition like crazy. So yeah.
Well, they are definitely really busy right now.
Cool.
What is Providence?
Providence, yeah.
What is it?
It's a hospital network.
Oh, right, okay.
Or healthcare provider.
Mm-hmm.
Paul can probably describe it better than me, but at a high level, it's hospitals and healthcare. Like here in Tri-Cities, they own. Did they buy Cadlick?
Yep.
Yeah.
So I was a Cadlick employee.
Okay.
And then they absorbed the IT department, and I got shuffled around till I ended up in cloud.
Yeah.
But,
and they've been buying up hospitals all over the place. I worked for a organization in Orange County that was a very big, very exclusive hospital in the Orange County area that got bought up by them. And Hoag Hospital, but yeah.
Yep, Hoag. Yep. We were shutting down parts of the Hoag data centers, moving them to the cloud.
Yep.
Yeah, we're from Texas to Alaska with, 3,000 people in India.
Craziness. Cool.
Anyway.
Well, let's get back to Kevin doing his thing, but yeah, there's all sorts of applications for this that you wouldn't necessarily see right away that are being used everywhere.
Yes, absolutely. Anybody else?
I think the common term that describes this is treating infrastructure like cattle, right? You just shoot it in the head.
If nobody's heard that analogy before, it's like, are your servers cattle or pets? And you want to get to your servers being cattle, right? The idea being that if your pet gets sick, then, you take him to the vet and you spend a whole lot of money and you feed them and you nurse them back to health. If your cattle gets sick, you shoot it in the head and buy another cow, right? So kind of a horrible way to say it, but basically you want your servers to be cattle, not pets, because when you try to scale, there's no way when you're managing hundreds or thousands or tens of thousands or hundreds of thousands of servers that you can afford to have people nurse back to health a server that got a virus or has an issue. Really, you just want to be able to delete it and redeploy it. And the way you do that is with things like Terraform.
Yeah. Exactly.
That's an interesting yeah.
That's how you become vegan.
All right. Anybody else? Like I said, no rush. Any other questions or before we move in?
No, keep going.
All righty. So the basis of this is, I just wanted to give a hello world kind of demo about how a Lambda deployment might work to show the workflow of this tool of Terraform. So I had one that I've been meaning to put on Terraform, and the workflow for it before was all manual because I didn't really want to. It's like a hobby Lambda that I just had doing some stuff. So to get it from 0 to 1, I compile the files, zip the files, and then you're ready to just drag it into AWS console, no big deal, super easy. For first time setup, I had to add environment variables and a scheduler or like a CloudWatch event rule, so that it would actually run when I wanted it to. So now Terraform kind of does those last three steps. So I just compile it, I give it the zip files, and then a plan, which isn't necessarily required, but lets you know what's going to change before you actually deploy or make the app or apply the plan in step 4. So at a high level, this demo is kind of just taking you through installing the prereqs. The meat of it is really what's going on with the configuration files and how do we develop those for our own infrastructure, and then kind of like one way to manage secret files. But then we can verify that they deploy with Terraform plan, and then we can actually deploy or Terraform apply that plan. So prereqs are basically just Terraform CLI. In this case, I'm going to be deploying to AWS Lambda. So having that CLI ready, I won't bore you there, but that's something that you'll have to do. So creating the configuration files. So we know that this infrastructure can be deployed with this special syntax, this high-level configuration syntax. So the way I went about it is you can get configuration templates or like a basic example from the registry, the Terraform registry, and then you can basically configure the arguments to fit your needs. So this is what the registry looks like. If you just Google Terraform registry, it's out there. And if you also Google for whatever resource you want to build, in this case, AWS Lambda function, and you can scroll down and it kind of gives you this basic example, which you can work from. So at the top, you see that there's this AWS IAM rule, which is basically like a permission. And then you have your actual AWS Lambda that you want to deploy. And you can see that we won't go super deep into this AWS permission, but it is required to deploy your Lambda, mostly boilerplate. So we'll gloss over that. And the real stuff that we want is this Lambda. So this is our infrastructure, right? This is our cattle that we will begin to not love very much or something. So you can see that it has file name, it has a function name, a role, which is actually referring back to that AWS IAM role that we had defined just above. The handler in this case is what's going to be invoked when this Lambda runs. So like that binary or that executable rather, and then some others, environment variables at the bottom, runtime. So eventually you'll end up with something like this. You'll create an infrastructure.tf file or like a main file, put it in there, and then you are kind of off to the races. So this code that we copied, boom, that AWS permission's in there. The other section, that resource, that AWS Lambda function, this is kind of a side-by-side of going from the template syntax and then just customizing it for mine. So Strava Elevation is really the name of my Lambda, of my code. So I put in the file name, function name, role, handler, that's the executable that runs. And then everything else. So at the bottom, you can see that there's a var dot syntax, and we'll go into that a little bit more later about how we want to manage our environment variables. But that's pretty much it at a high level. This is the final product for that resource, that piece of infrastructure that we're going to set up. And then this is a little bit more minor, but still required, is just the AWS provider. You need your profile credential set, right? Otherwise, nothing's going to happen. You don't have permissions to actually deploy this thing. and then region and anything else you want to add later. So that's basically the anatomy of this whole file: config, permissions, AWS Lambda, and that deploys our Lambda. So what we can do is, all right, can people see my terminal?
Yeah.
Okay.
Coming through here,
Cool.
fine.
So I cheated a little bit, but essentially the first thing you're going to want to do after you install CLI and you kind of have this thing groomed is Terraform init. And this will kind of just create the project. And then after that, we can go in and we have the code. Ooh, this looks like it got messed up a little bit, but that's fine. Hopefully this still works. This is the images that we were just looking at. So you can see that this AWS IAM role is here. This is the name, is kind of how the syntax is broken down. It's the keyword for resource, and then the actual piece of infrastructure, and then the name for the infrastructure, and then all the arguments within here. And let's go ahead and Terraform plan that and see if it's going to add what we want to the infrastructure, or if it's going to deploy how we want it. So plan, oops. So boom. If you scroll to the top, you can see that the IAM role is there in all of its glory, as is the Lambda function, and all of my secret variables. So apply. So really quick, you can see that I have one Lambda in here that's a different name. This is the actual one that I rely on. But if we go back here and I Terraform apply, you can see that it's going to set up another one of a different name. So we'll hit yes, basically showing us our plan again. And now we're in the process of deploying or applying that plan. All right, so 2 resources added, 0 changed, 0 destroyed. We can go back here and you can see that in the last couple seconds, this other Lambda has kind of spun up. I guess one thing that I might have jumped the gun on is kind of secret files. So one of the ways to manage it, this isn't necessarily the best way, but you want environment variables in your Terraform, but you don't want them in your source control, right? And you want your Terraform in your source control. So where is the line? How is that divided out? So the way I did it for this project is you have just this variables.tf file, and each of these variables takes parameters in the curlies. I just didn't have any. And this file is versionable, right? We're not ignoring any of the .tf files yet. We don't have any plans to. And this is kind of your interface for your variables, even though nothing's being defaulted. That actual defaults or values I set up to run on my Terraform.tf vars. So .tf vars are actually variable files. So this is kind of similar to what you would find in like a .env file. You know, it's plain text client, but at least it's only ever on my machine and it's not going to be versioned. And then this gets back to the other, that variable var.syntax. You know, they're defined over here, so you can reference them in your actual Terraform file. Part of setting up Terraform in this case is going to be getting rid of the Terraform files that you don't want to version, so .terraform, .tfstate, and .tfvars. So you're going to want to make sure to have that in there. And this is the basic structure for how I set up my environment variables. Is Terraform.tfvars on the right-hand side never really goes anywhere. That's either just on my machine or the build agent or whatever you have. And then the variables is just that way we know that we need these variables, and we're not just looking at the infrastructure or main.tf to figure out that, hey, this says var.this, the var.this, we need all of these things. So we kind of already went through Terraform plan, Terraform apply, and now we kind of have seen that demo really happen. Well, one of the things that I left off from before was to add the scheduler, right? We have this Lambda, but unless we trigger it manually on AWS console, it's not really going to do much. So this original Lambda that was deployed previously has an event bridge, but this one does not. So let's go figure out how we want to add that. So this is basically the next piece in what we're going to add to our infrastructure. There's a schedule, so there's a cron expression to tell us when we want to run. The name of this is just during day. These are the hours that I am generally riding my bike on any given day, like sometime between this time. So that's what I ran the schedule for. We need to know what to trigger. So this is a target linking that CloudWatch event rule above, that schedule, and the function. And then we need to give it permissions to actually trigger or invoke this function. So this is what you need to kind of have that Lambda be on a scheduled event. So really quick, bouncing back over here, I have those pieces of infrastructure down here. I'm just going to uncomment those. We can run Terraform plan again and see that those 3 resources are going to be added. So boom, there's the CloudWatch event rule. There's the CloudWatch event target and the AWS Lambda permission. And we can Terraform apply. Yes. And then we added those 3 resources. So if we go back here and load, you can see that it added that event bridge, that CloudWatch event. So now it'll run whenever when we want it to. That's pretty much it for the demo, just kind of that workflow of we wanted to add this thing initially and then we wanted to extend it. I glossed over Terraform registry earlier, but any piece of infrastructure that you want, I'm sure everybody here has something in mind that they want to build out. So you can go find that either under your provider or there's these modules. So modules are small reusable Terraform configurations that you manage group or related resources as if they were a single resource. So these are kind of community provided or provided by an actual, one of these big guys. So you can learn more about these here, but that's pretty much it.
Yeah, I think that's a key thing like to mention, right, is this idea of providers. So the idea is that Terraform lets you write this code that can be interpreted to do different things. But say you are, I don't know, DreamHost, right? And DreamHost hosts virtual machines and applications, et cetera, and they offer a REST API publicly. since they have a REST API to create DreamHost virtual machines, they could decide to develop, or you as an independent developer could write a Terraform provider that takes Terraform code as input and then deploys DreamHost virtual machines configured a certain way using Terraform. So, as infrastructure or service providers, it is up to you to make or have somebody write one for you, a Terraform provider. And if you need special keys, like, I need your DreamHost username and password in your DreamHost provider, you can add those things. And we saw a lot of AWS Lambda specific stuff in Kevin's example, but you can have both proprietary and non-proprietary data in your stuff. So, yeah.
Are there equivalent commands for tearing down things through Terraform once you put them up, or do you usually just go into your hosting provider and tell it to shut down?
Terraform destroy.
Yeah, you know it. Oops.
Okay, so essentially destroy it. The other thing is, so once you have a file there and you deploy it, if you deploy it again, does it redeploy the same thing, or does it create a whole new instance? I guess I'm thinking towards where you tweak something, or maybe you want one particular thing and you just want multiple copies of it. Would you nest it within what you do to get those multiple copies?
That's a good question. So the first part of that was, if you redeploy, is it a unique instance or not? So sometimes, depending on how you change it, it might be, or it might try to update it. Although I've seen it more often than not, it's actually a new thing. So if I wanted to do a new Lambda, it would be, or make changes to a Lambda, it would be a new Lambda. As far as how you do multiple things, I think that is a little bit out of my area of expertise.
Yeah,
but
I can make a brief comment there, which is you can. So, for example, you can write Terraform code that says, I need a 3-tier application that's going to have a web server, an app server, and a DB server. And in the web server tier, I want 3 web servers and then a load balancer, and it'll deploy 3. What you go to from there that you don't see in Terraform is what a lot of infrastructure providers call auto scaling, which is you do something like what he was doing here with CloudWatch, where you watch metrics, CPU utilization, memory usage, the amount of time that loading a web page takes. And if it goes above a certain threshold, then you deploy more web servers. If my latency or my database request time or whatever it is goes above 300 milliseconds, deploy another instance. And there are actual...
And that would essentially be a nested little thing within your Terraform configuration file.
Yeah, or you would be using code that would basically, when you have something that that loads your base website every 5 minutes, right? And if the load time for your website goes above 500 milliseconds, it goes out and edits the Terraform file and changes the number of web instances from 3 to 4, or it reads in the number of instances and increments them 1 and then reapplies it. And you can do this idempotent application where essentially it looks, and if your Terraform file is changed from 3 to 4, it just adds 1 new one. Or it depends on how you want to set it up. But Terraform in and of itself doesn't solve that problem. You are usually tying it into some sort of performance monitor that then does the thing to add another instance.
Okay, because once you run Terraform, it's gone away, it's not doing anything. Something else has to do this monitoring.
Exactly, yeah.
It sounds like.
Terraform just describes how the infrastructure should be built, and you're going from saying I need 5 web servers to saying I need 6 web servers. And the way you do that could be a number of ways. One way to do that is just to edit the Terraform file and edit it and say number of web servers instead of 5, X that and make it 6 and reapply and run it again. Or you could have a Terraform file that just deploys a new web server. So there's a number of ways to do that, but Terraform is usually not the thing that's doing the performance monitoring and continuously firing. It's just the description of what the infrastructure should look like tied to the provider that actually deploys it, right? So you make a file that says, I need 10 servers with this. And it's funny because depending on the provider, you see different things. Like VMware's provider files for virtual machines say things like how many CPUs, how much memory, how much disk space, et cetera, to set these out. Totally don't see that when you're using a Lambda, because Lambda is quote-unquote serverless. It doesn't define CPUs or memory. It defines these other characteristics that are for it. Now, when you're doing
understood, so those characteristics would just be put in the Terraform file as one of the parameters, and
and interpreted by the provider that's provided by the infrastructure host. So you as VMware or you as DreamHost or you as AWS takes that Terraform file and reads it and does what you can with the parameters included therein.
And it would also seem that in most common applications, you would not create a whole nother separate one, because I guess most of the time you're going to bind this stuff to some public domain names. And if you just created a whole new one, it would suck up those public domain names, and you'd have this other stuff sitting there with nothing, no incoming phone calls.
Yep. Yeah. That's exactly right. Like in that particular scenario, and that's where you get into when you apply the Terraform. Does it deploy a new instance, or does it just reconfigure the existing one? And that is something that's determined by how the provider implements it. If you're a DreamHost and you write the DreamHost provider, maybe you do something like you say unique application ID, and if they give you the same unique application ID, then you just reconfigure the existing instance. If they give you a new one, you deploy new infrastructure. It's up to the provider to how to determine the input file and what to do with it.
No, okay, so that makes a lot of sense with a unique application ID, because that would be something easy to control on your side and not so much in the provider. Yeah, I would think I'd hope the providers would have a little more consistency in the way they did it between providers.
Yeah, there's consistency in certain things, like the way you do load balancers and the way you do multi-tier applications. But like he's looking here at the virtual machine provider. If we look at like the load balancer provider, there's a lot of consistency. But if you look at something like the Lambda provider, it's going to have a lot of things that are very specific that only make sense to Lambda probably. So
yeah.
Okay, well that part I get. I absolutely get. Yeah, Lambda is way different than just a server.
Yeah.
Yes.
Yeah.
So what's the, like, if you're deploying a Lambda function that's performing whatever, is there, like, if you're just updating that function, is there some sort of crossover that happens? Like, is it just updating it, and then if that function was performing something that gets scrapped, or is it creating a new one and then scrapping the old one, so there's some form of crossover? How does that work?
I think it pretty much destroys the old one and then recreates the new one kind of in the same time. So it's possible that if it...
Can we look
at most providers, it doesn't destroy the old one as long as it conforms to the plan that you're pushing. You can double check when you do it because of that plan step. But for most of them, when you change the configuration, I mean, the idea is that it'll change the already deployed resource.
Can we look at one of your Lambda files and see if there's any unique identifiers in there? Like, I'm not sure what would be in there, but a lot of the infrastructure providers basically have something where it's like, if this thing's the same, then it redeploys it and deletes the old one. But if not, then it just deploys a net new instance. And that's something you have to watch out for with automation, right? Is like, oh, every time I push it, it's deploying a new one, but it's leaving the old one out there.
Well, yeah, that's what I was thinking. If you're doing this via automation, then, you know, are you able to check that plan before it gets deployed, or is it just something that sort of happens and hope for the best?
We use that as part of the gatekeeper step. Right?
Look
Kinda
at the
like you would
publish
with the
option
merge.
there. See where it says publish? Option whether to publish creation changes a new Lambda function version defaults to false. So if publish is true, then it's going to be a new one, and if it's false, it's going to redeploy the old one. Maybe, I don't know.
Something, yeah.
Sorry, what were you just saying, Paul?
Yeah, I was just saying we use that plan step as part of the same way you would with a pull request, right? It goes to the plan. Somebody can go check the plan and actually be the person responsible for pushing it and being there if things break. But we do occasionally set up certain things to push automatically once the merge has occurred. In Azure, the Terraform by default takes over the entire resource group. So everything that you deploy into a resource group is expected to match your Terraform file. So if something's missing and you push a plan, it'll delete. It'll delete it if it's not in the plan file. But if it's the same, it actually holds on to a TF state from wherever you pushed, and that TF state has all of the backend identifiers for all the resources that were deployed. So it knows whether or not to deploy new ones. And when you do the initial test, before you actually push the change, it goes out and talks to the provider, checks all those IDs, makes sure they all match, figures out, what it's going to do by pushing like an ARM or a CloudForms, depending on your provider, and verifying that it's really going to do what it thinks it's going to do.
Mm-hmm.
Yeah, so that's something that became very important and that VMware, when writing their provider, had to contend with, is this idea that a well-implemented provider is idempotent, which means if somebody takes the same thing and pushes it 100 times to you, you look at it and you go, nothing changed, I'm not doing anything, bye. Nothing changed, I'm not doing anything, bye. And the only time that you change anything is when they push a file to you that has something that's different. And if possible, you do the minimum amount of work to get to the requested state. So if they changed a firewall port that's open and that's it, all you do is change the firewall port versus deleting everything and redeploying it all just to change one little, port that's open or something like that. And that is up to the provider to implement well, because a poorly implemented provider may just be like, oh, well, it looks different, blow everything up and redeploy it all then. Mm-hmm. And that's quote unquote a valid way to run the provider. It's just not efficient, right? So it varies greatly when you're talking about something like Terraform, but depending on how well the provider has done of implementing Terraform, right? Like they're like, oh, you just changed this one thing, I'll just go change that, versus, oh, you changed a port and now I'm going to delete 36 VMs, redeploy them, reconfigure them, etc., to change one setting.
Yeah, we just take away people's rights to do the direct exchanges.
Yeah.
If it doesn't work in the Terraform, then either your Terraform's wrong or you need to go find an admin.
Yeah. So. And that's why we have test environments, right? Like you write your code, you deploy it to test, and if it blows up, you're like, yeah, you're not pushing that to prod. You didn't pass your tests. Sorry, man.
Well, that's where we were talking about that test step. So we have a test tenant or a test set of accounts in AWS.
Yep. They even use different credentials, right? Different keys, everything.
And so when you push that code in and you do a pull request, then it goes and actually does a deploy all the way through into AWS. And if that deploy fails, it's going to be right there on the pull request. Right?
Yep.
Until that pull request is passing in the actual test instance, then forget about it.
Yeah. Yep.
But it's good. I mean, even if you only have one or two people, it's still really nice, right? I mean, even when I'm working on code all by myself, I love the fact that I push and things go through and I know right away what's going to happen, and I don't have to go in and actually fiddle with any of the settings manually.
Mm-hmm. Yeah, it's a cool technology, and it has gotten adopted by a lot of orgs. Like I said, VMware as a company, like for a really long time, tried to ignore it and had their own things that did the same thing. And everybody was like, when are you going to do Terraform? Like, we use Terraform for other stuff, and eventually made a provider. And now you can look at this and see, look at all these providers, and they have verified providers versus unverified ones. Yeah, there's like DigitalOcean, Exascale, F5 Big IP. Yeah, I mean, like all these different ones for doing different things in every combination therein. So you could have DigitalOcean also using Cloudflare and be able to write Terraform code that deploys to that. And the promise that people are looking for is, if I write my app and I'm hosting it in Amazon, and then all of a sudden Amazon ups their prices, I should be able, if I wrote it using Terraform as the infrastructure provider, to move it to Google Cloud Compute or to whatever new person comes along on the block with minimal effort, because I can take my Terraform code and now point it at the Google Cloud Compute or the DigitalOcean provider instead of Amazon, right? So it's
but now you sound like you're selling me Java.
Yeah, and that's what Java like tried to do for a long time. But look how popular Java is, and I mean, I will be the first person to say and admit that Java's performance is absolutely horrible, and I would never recommend it to anybody for developing a new application. But there is some truth to the
It can be
portability
good,
of it.
depending on how you write it.
Yeah.
And I will never get back the hours I spent in VRO. So
VRO, like vRealize Orchestrator? Did you have to?
Yes,
I'm sorry.
vRealize Orchestrator.
Yeah, it's JavaScript.
I wrote a lot of nasty JavaScript in
Okay.
VRO.
Yeah, it uses the Mozilla. Oh God, what was that? Not Apache, but whatever the Mozilla JavaScript engine was. I can't even remember the name of it.
So happy to be writing Terraform for my VM instead of VRO.
I know a lot of VRO, so I feel for you. If you end up needing some help with that and want a second set of eyes on stuff, feel free to reach out to me. But you're not going to hear any pushback or argument from me on anybody that complains about having to write in that. Yep. Cool. Awesome presentation, Kevin. That was very informative and is a good demo of kind of what you can do with Terraform.
Yeah.
Thanks. Yeah, it's interesting because you're seeing more and more of this. So it's a HashiCorp. HashiCorp owns it, but it's open source, and anybody can use it, and anybody can write a provider. So the interesting thing is they're not necessarily directly profiting off anybody using Terraform, but at the same time they still own Terraform and they control the I don't know what you want to say, the standards,
specification,
exactly. So take that with what you will. Like, I guess it's better than a fully proprietary system, and it's seen a lot of industry adaptation.